Hello everyone. We are presenting you current electricity for class 10th part first, brought to you by Tranquil Science. Our motto is to learn more and grow more. Topics to be discussed in this video are: first we discuss charge on body, then current in conductor, then potential difference, and the last is a resistance. Electricity is very common name in our surrounding. We even couldn't breathe without electricity. So here comes some common day-to-day life examples of electricity. Sometime when you touch any metallic doorknob you get shock. So it is also a kind of electricity. And many of you have done this experiment in your early days, just rubbing your comb and attracts bits of paper, and you say this is a magic. It is due to electricity. And the third one, when you walk on a road, then there is electricity in between your sole of your shoe and road surface. And if you touch any metallic conductor, you get a sudden shock, then your hair raise, and in common language you represent shock laga like this. So it is all this kind of electricity which is going on in your surrounding. After studying about electricity, the first question which comes in our mind, how bodies get charged? Because if we look at the structure of an atom, it contains equal number of protons and the equal number of electrons. That means all positive charge is equal to the all negative charge, which cancels each other, and at last atom we get is a neutral. That means it contains no charge. Now we are going to do one experiment. Now we are going to do one experiment. We have taken one glass rod and one silk cloth. We just rub glass rod with the silk cloth. Then the strange thing will happen. Earlier they were not at all attracting or repulsing each other. They were just neutral. But after rubbing silk cloth on a glass rod, we can judge that the glass rod will start attracting the silk cloth. Why? Because on rubbing, glass rod get positive charge while electrons get negative charge. That means glass rod loses some its electron, then it get positive charge, while silk cloth gains some electrons from glass rod. That's why it become negative in charge. So imagine if silk cloth asks glass rod, are you positive? So what will be the answer of glass rod? Yes, I am positive because I lost an electron to you. So we can conclude that if a particle loses electron to other, then it will obtain positive charge on it, and if a particle gains electron from others, it will obtain negative charge on it. Now let's we discuss something about the history of electricity. Whenever we talk about electricity, we memorize the famous kite experiment of Benjamin Franklin. But is he the father of electricity? No, he is not at all the father of electricity. Originally, electricity was invented by Greek people who accidentally found a material called amber attracted to the straws. So after the name, we get the word electricity. Up to now we have discussed about the history of electricity and the cause of electricity. Now we are going to discuss the types of electricity. Electricity are of two types, static electricity and the current electricity. With their names we can judge their nature. Static. When we study charges at rest, that is known as the static electricity. Is there any example around you of static electricity? Yeah, there is a very famous example in your surrounding and very common. Generally you have seen lightning in the sky. So lightning is an example of static electricity, as it is not in motion but still at a place produces a spark. That's why it is a static electricity. Current electricity, when we study charges in motion, that is known as a current electricity. Example, very common, electricity coming to your home is an example of current electricity. And in class 10th we are going to study the current electricity in detail. So the question which comes in our mind is that what is this current? As we studied about the charges earlier, when these charges are in motion, then it gives rise to the current electricity. Current. The rate of measure of the flow of charge moving through the cross section of conductor is known as a current. Now, if we look at the conductor, like we can take a copper wire, inside this copper wire there are number of free electrons which are moving here and there. If we measure the rate of flow of moving these free electrons through the cross section of this copper wire, that is the current. We should keep in mind that moving charge is not only the free electrons, but it may be cations or anions. For metals, movement occurs because of the motion of the free electrons, whereas for electrolyte and ionized gas, the motion is because of the cations and anions. Now the question comes in our mind that what is the direction of current? Current direction, we are taking conventional directions, or we can say the simple direction of electric current is taken from the positive to the negative terminal of the battery, or you can say cell. For example, in a copper wire, free electrons, which are negative charge particles, move toward the positive terminal of the cell. That means if we talk about the positive charge in copper wire, they move towards the negative terminal of the battery. So conventional direction of the current is from the positive terminal to the negative terminal of the battery, as shown in this figure. Conventional directions of an electric current is considered to be in which positive charge move. So we are taking it from positive to negative terminal of the battery. Whereas in metal conductors, we are considering current carried by the free electrons. So the conventional direction is always opposite to the flow of free electrons. The important points which we should keep in mind about the current, that is the symbol is I. Formula for current, this is equal to Q upon T, means charge upon time taken. SI unit of current is ampere and denoted by the capital A, whereas the small quantities 1 milliampere is equal to 10 to the power minus 3 ampere, while 1 microampere is equal to the 10 to the power minus 6 ampere. So we can define 1 ampere like this. If 1 coulomb of charge flows through a conductor in 1 second, then the current through the conductor is said to be 1 ampere. So we know that current formula is Q upon T. So 1 ampere current is equal to, in place of Q we can write 1 coulomb, and in place of time we can write 1 second. So that's become 1 ampere is equal to 1 coulomb upon 1 second. And the device used to measure the current is ammeter. Always connect ammeter in series with electric appliance. Now we are going to discuss the concept of the potential. Before jumping to the current potential, we should check out the following cases. First case is that, have you ever seen a ball rolling down inclined plane? In this case, we apply no force to ball. Ball just rolls down from the higher potential to lower potential under the gravitational pull. In second case, imagine you have two buckets. One is filled with the hot water while other is filled with the cold water. When we keep them together, means they are in contact with each other, then what will happen? Heat will flow from the hot water bucket to the cold water bucket, and this movement continues till they become equal in temperature. So we can conclude that the motion of heat is also direction specific, and that is from the hotness to the coldness. In third case, let us consider we have two containers filled with the water at the different heights. If we connect them through a pipe, then what will happen? I suppose you know this. Water will start flowing from the upper height level to the lower height level to attain equal height balance. So in this case, we have studied that if there is a height difference from the ground, then the water flows from the higher to lower. So with above example which we have discussed earlier, like case of a ball, water and heat, we come to know that if there is a potential difference, then the movement will occur. That can be in case of a ball, that can be in case of a heat, that can be in case of a water. Similarly, if we create potential across the ends of the conductor, then the current will also start flowing from the positive potential to the negative potential. But first we should check out that what is this potential. Positive potential means where loss of electrons occur at that place, that creates a positive potential. Means if we are having less electron at one place, that place give rise to positive potential. Negative potential, when there are excess of electrons at one place, that creates a negative potential. So the electrons will start moving from the negative potential to the positive potential. And opposite to the flow of electron, current is said to move from the positive potential to the negative potential. As we discussed about the current movement from the positive potential to the negative potential, but the biggest question is that who maintains this kind of positive potential and negative potential in the circuit? So the answer is cell. So cell is a device which creates positive and negative potential and make current to flow from the positive potential to the negative potential. Actually, all is having two terminals. The cell is having two terminals. One is positive and other is negative terminal. Positive potential is a place which is having less number of electrons, and the negative terminal is the place in the cell which is having excess of electrons. So the electrons want to migrate continuously from the negative potential to the positive potential to fill up that empty space, and the direction of current we are taking always opposite to the flow of electrons. So direction wise the current will move from the positive potential to the negative potential. So we can define potential like this: the amount of work done in bringing a unit positive charge from infinity to the field. For example, let us consider we are going to bring this positive charge which is placed at the infinity, or you can imagine at far away place, to bring it nearer to this positive charge. So what will happen? This positive charge will repel the incoming positive charge, but this repulsion, we have to cross this repulsion, so we are doing work done against this repulsion, and this work done which we are going to do against this repulsion is stored as a potential in the circuit. So we can finally conclude that potential is the amount of work done in bringing a unit positive charge from infinity to the point in the field. Now what will be the SI unit of volt potential? SI unit of potential is a joule per coulomb, or we can simply write as a volt capital V. So we can define 1 volt is equal to 1 joule upon 1 coulomb. That means when 1 joule of work is done to bring a 1 coulomb of charge from infinity to the point in the field, then the potential in the circuit will be the 1 volt. And we can measure this potential by the device voltmeter, and this device is always connected in parallel with the electric devices. Our next topic to be discussed is a resistance. What is resistance? First question which comes in mind, what is resistance? So in a simple language, resistance is a kind of obstruction in the flow of electrons. Let's take this view. We are having one wire, and when the wire is simply placed, then the electrons inside it are in random motion. They are colliding with each other, they are following zigzag path, they are colliding with the walls of a wire. But when we place cell across the ends of this wire, then the electrons will get a perfect direction of the movement. They will migrate towards the positive terminal of the cell. So in this type of movement, they collide with each other and with the positive ions which is coming in between their path. So the drift of electrons move with the accelerated speed. Thus the metal wire offers resistance to the flow of electron. I suppose you not get an idea what is actually resistance. So we need to take a common life example. So we are imagining a metro scene. Imagine yourself traveling in a metro, and you need to cross all these obstructions to go to the other end of the metro, then what will happen? They all oppose your motion, but still you are drifting towards other end. Similarly, resistance is the kind of obstruction in the flow of electrons in the conductor when connected in the circuit. Here we are discussing about the factors on which resistance depends. Resistance depends on the nature of material. Nature of material means whether the substance is conductor or substance is insulator. Conductor means more free electrons, and with more free electrons the motion is continuous and obstruction in the flow of current will be less. Therefore, for conductors the value of R, that means resistance, is less, and for insulators the value of resistance is more. The second factor on which resistance value depends, that is the length of conductor. As we have earlier discussed examples of a crowded metro and you are traveling across it. Imagine if this metro is more lengthy, then the more obstruction in your way. Similarly, if the length of conductor is more, then there will be the more resistance and it's difficult for a free electrons to move continuously. So with more length, value of resistance is more, and is for short length the value of resistance is also less. The third factor on which resistance depends, that is the area of cross section. In this figure you can check out what is basically cross section. So here we can think that imagine a case of a tunnel. Earlier 50 students were walking on open road, and imagine now these 50 students were asked to pass through a small tunnel. Then what will happen? I guess you know that there will be more hustle bustle when they walk through the tunnel, because more obstruction in their flow, they will collide with each other, they will collide with the walls of tunnel. Similarly, if the area of cross section is more bigger, then the value of resistance is less, but this if this area is small, then the value of resistance will be more. And the fourth factor on which resistance depends, that is the temperature. So more temperature of any conductor, more resistance will be there. Earlier we have discussed about resistance, why it occurs in the current carrying conductor. Now we should know how we can represent resistance in the circuit. So here is the symbol through which we can represent resistance in any circuit. Now turn off SI unit of resistance. SI unit of resistance is ohm. It is named after his inventor George Simon Ohm. As we studied, resistance acts as obstruction in the path of current, so we can use it to alter the value of current in the circuit. Like if we increase resistance value, the current would decrease. If we decrease resistance value, current would increase. If we want to put resistance in the circuit, we can put in the two ways. First one is a series and the second one is a parallel. There is a first figure when we can connect resistance in a series like this. Here we arrange three resistance of magnitude of 100 ohm, 300 ohm and the 50 ohm, all connected one after one. And this is a situation where we connected resistance in parallel. We have three resistance R1, R2 and R3, and we arrange three resistance parallel to each other like this. Now we are going to discuss the concept of the potential. Before jumping to the current potential, we should check out the following cases. First case is that, have you ever seen a ball rolling down inclined plane? In this case we apply no force to ball. Ball just rolls down from the higher potential to lower potential under the gravitational pull. Up to now, we have studied that what is resistance, how we can connect it, and how we can use it. But the biggest question is that can we produce resistance by using any device? So the answer is yes, we can produce any value of resistance which is required in a circuit. Actually, resistance device is nothing but a special wire is fitted which offers obstructions to the flow of current and lower its value. So have a look over the type of resistance which we can use in our daily life. First type, this is the kind of resistance which we use in our inverters. Second one, this is a kind of resistance which you have ever checked in your integrated circuit, like in computers, in mobile chips. This kind of device with the different color bands you have seen, this is also the one kind of resistance. And the third one is this kind of resistance box which you generally seen in your school box can produce any value of resistance. And the last one is rheostat. If you want variable resistance, means whose value you can change, so you can use rheostat which gives you the different value of resistance with its sliding bar.